where he created the industry's first PCIe to USB 3.0 peripheral controller. Following the presentation, we'll have a live Q&A with Jimmy. You can submit questions at any time during the session using the Q&A box on the right-hand side of your screen. We will provide attendees with several helpful resources in the Handouts tab, and we encourage you to check those out. At the end of the session, I'll be announcing 2 winners of this live session giveaway and today's grand prize winner. Thank you so much for joining. With that, I'll hand it off to Jimmy for his presentation.
Hello, my name is Jimmy Cho. I'm the product marketing for USB product at Infineon. Welcome to today's webinar. Today we're going to talk about how we can unlock USB 20 gig performance in test and measurement applications. So we're going to start with the market trend and the challenge on USB 20 gig. And we're going to talk about Infineon's latest easy USB FX20 and how it can solve the problem. And we're going to talk about the features, development tools, and reference design that using FX20. We'll also talk about the application and success story that the using easy USB FX20. At the end, we're going to go over the portfolio of easy USB, and you can see that the what other option can be used in test and measurement. Why USB in test and measurement? Right. USB has become one of the most widely adopted interface in test and measurement. But why? Since the year 2000, when USB 2.0 was introduced, the USB interface has gradually replaced the legacy GPIB interface and the used in the test and measurement, the class devices. And the main reason that the USB is the good choice for this application, number one, will be, of course, the high bandwidth. Now with the USB 4 version 2 introduced a few years ago, that now you can using the asymmetric USB 4 connection with up to 120 gig the data bandwidth that can transfer lots of the raw measured data through USB. And second reason that is the simplicity and ease of use. Right, USB is by far the de facto standard that the consumer can understand. Right, you simply just plug in the cable and you're good to go. Right, and also the driver integration with the application is also seamless. That the most of the application engineer would not even need to worry about the driver development by using the USB device class driver. And the compatibility for USB is really the greatest thing for USB, right? So you don't worry about which the USB port you connect to. It's always work, right? It's backward compatible all the way to even USB 1.1 full speed connection that introduced almost 30 years ago. And USB is compact and portable. So by using USB, right, and you can save a lot of the space and traditionally all the test instruments that are very big and bulky, right? And now with the faster personal computer that you can get, right, you can leverage lots of the function of the personal computer, such as big screen, touch screen, right, and lots of memory processing power. You can simply just need the building a device that to the analog from to getting your data. And of course, by doing this, it's cost effective, right? And this is the much lower cost solution, and also development is much shorter time and also very easy to maintain with the less complex device. And USB with the USB PD, right? And now you can deliver up to 240 watt of power, and that's enough for the even for the most complicated and the power hungry device, and the USB is scalable. That it's easy to expand by using multiple devices on the same computer, or you can even expand through the same USB cable with the composite devices. And USB is building with the error correction and recovery, so it's reliable and stable. So let's take a look at the history of the USB. Back in 1996, USB 1.0 was introduced by Intel, leading by Intel, to replace all the legacy PC peripheral connectivity, such as PS2, serial port, parallel port. I'm not sure that you have heard of any of those, but back in the day, it was difficult to connect all this peripheral to a personal computer, and so Intel want to have this universal way of connecting the peripheral to computer by using the USB. And initially, it was designed for only 1.5 megabit for the low speed device, and up to 12 megabit for the full speed device. Apparently, that speed is not enough for many applications, such as the mass storage. So in year 2000, USB 2.0 was introduced with the 10x of the 40x of performance, that you can go up to 480 megabits of the throughput. And that's the year that when USB number of application in USB explode, and grow very, very fast. So now it can start using the external storage device, such as DVD-ROM drive, the external hard disk drive, and also the webcam devices. And I think that's the time when USB start being used in test and measurement for delivering data and controlling all the test and measurement devices. Okay, so in speed is never fast enough. We always need a faster speed. So within 10 years, the USB app introduced USB 3.0 with the additional super speed pair, totally full duplex the connectivity, in addition to the half duplex, the USB legacy 2.0 connection that deliver up to 5 gigabit of the bandwidth. And that again has introduced many new applications, such as the HDMI video capture, industrial camera, and so which can leverage the faster speed. And in 2013, USB 3.1 was introduced by doubling a speed to 10 gig, and this time we use the much more efficient encoding scheme, and so the actual data throughput can be a lot more higher than what the older encoding scheme AB10B can achieve. And the 2017, right after USB-C connection was introduced, so now with the USB-C to C cable that with 2 lane to support the reverse connection. So now the USB can leverage more data through 2 lanes of the data pipe to deliver 20 gig of performance. And then the USB keep continue that grow in the spec by end of the 2022, that now we have this USB 4 version 2 that's supporting up to 120 gig of performance with the symmetric arrangement on the data transfer. One question you might ask is after 2013, right, when the USB 10 gig was introduced, we don't see that many that the USB 10 gig application, especially in test and measurement. But why? So the challenge that to answer the question, we're going to understand what's the challenges beyond USB 3.0 that so we know that the number of applications have been keeping growing since the USB 2.0 was introduced and continue in USB 3. However, the after USB 3.1 that growth rate has almost stopped. So you only see that the master device can leverage the faster USB connection, or the display using the display port over USB cable. And other than that, you don't really see many of the USB 10 gig or even faster the speed of the application. The number one reason for that issue, that the problem that or challenge we see is there were limited building blocks for the USB 10 gig or higher speed, and so when you want to design a device that with the USB 10 gig interface 10 years ago, right, and the only choice you have is an APGA that with the has-be SerDes and connecting with the an external retimer or redriver, and of course you need to add another USB 2 transceiver to support backward compatibility. Then on top of that, right, you need to design your own APGA. You need to write the RTL code to support all the USB protocol, right? And so everything is very complicated and very high investment to do it with APGA. And another problem is the cable length that for USB, right? So we know the maximum cable length for USB 2.0 was 5 meters, and also limited by the half duplex protocol. Then you need to meet the turnaround time before host can time out the packet transfer out. So that 5 meter was the limitation that going to the 5-tier USB connection. So, and it was also understood that the faster you go, the cable will go shorter. USB 3 was typically limited to 5 meter passive cable. If you need anything longer than that, likely you need a redriver or retimer or even optical cable to support longer USB connection. And that the higher cost of the ATIC cable also prevent the main application that can adopt faster USB connectivity. All right, the last challenge, of course, the complexity in the development and also interoperability that you need to maintain with the entire USB ecosystem. So software is the key that to make successful. So how where to find a good software development tools, right? And include the firmware driver application, right? And those in combination can be pretty difficult to develop and maintain. So that's another key issue that with the previous two that we prevent the whole industry that they moving to faster USB. So we talk about the history before that and we know USB 10 gig spec was introduced in 2013, and the 20 gig so-called the USB 3.2 Gen 2 by 2 that was introduced in 2017 after the USB Type-C connection was introduced. And there were also the host side, the support for the USB 10 gig starting from 2014, and the supporting 20 gig starting from like 2021 that in many of the Intel host controllers. So by now, most of the USB Type-C port will support the USB 10 gig connection, and even many Type-A port will also support 10 gig. And starting from, I think, early this year, you can start seeing the laptop with the Intel Thunderbolt 4 and the DP 2.1 support that can deliver USB 10 gig performance. And so that's really a great thing for the ecosystem to grow. However, that we talked about in the last slide, you can see very, very limited number of application until 2024 when we introduce the Easy USB FX10 and FX20. So FX20 really just extend our legacy Easy USB FX3 which is the industry gold standard for the USB Pro 4 controller. It's probably the most widely used general purpose controller in the world. You can find lots of the reference to FX3, and so very easy to use. Then FX20, the next generation of FX3 with the ultra fast, the 20 gig LVDS interface that can deliver the data for the fast USB 20 gig connection, and that total bandwidth comparing to the FX3 is over 550% faster. So that's FX3 was limited to the Gbps bus with only 3.2 gigabit of performance. Now with the USB 20 gig and LVDS interface, now we can boost performance up to 17.6 gigabit per second. And because we learned a lot from the all the application using FX3, we know that the many video application using FX3 so we try to optimize this next generation FX20 to deliver faster or more efficient and less complex for application in machine vision cameras or video from grabber. All this for very popular application that using FX3. So and also we have seen that the great demand and higher bandwidth in the MR headset, the mixed reality headset, and 3D scanners that can also leverage the faster speed with the FX20. Lastly, is the test and measurement. I think the FX20 that with 20 gig of performance that can definitely boost the performance greatly for the spectrum analyzer and mixed signal oscilloscope or large analyzer applications. Here's the main feature for FX20. So begin with the USB 3.0 Gen 2 device port, which can support 20 gig, 10 gig, 5 gig, and 480 megabit. It's integrated the PHY that we have designed. With a 2-lane support, it can connect directly to the USB-C connectors. And with proper orientation detection and correction, that you don't need to worry that which side of USB cable or even the polarity of the differential signal can be swapped automatically, and that will make the PCB layout much easier. Okay, and so the CPU we use in FX20 leverage from the Cyber's famous PSoC6 CPU architecture with the one Cortex M4 running at 150 megahertz for the main application, and additional Cortex M0 CPU core at at clock of 100 megahertz for the security and housekeeping jobs. For the first time, we also integrated the 512 kilobyte of flash to store the book code and the firmware application, so you don't need external flash to store it. And we have separate the program memory from the buffer memory. So you have dedicated 128 kilobyte of the SRAM for your program, and the 1 megabyte of SRAM for the data buffer for DMA transfer from the from your source to USB. And for that, the connection to your data source, that we now have the 2 port instead of 1 from before to support high bandwidth data transfer, and that can be programmed to be either LVCMOS or LVDS. In LVDS, you can use the 16 lanes of the differential data with only RX direction at 1.25 gigabit per lane, so total of the 20 gig of the bandwidth with the 16 lane of the widening connection. If you program them into LVCMOS mode, the 32-bit bus can provide up to 10 gig of the bandwidth in RX direction with the 160 megahertz DDR clock support, and the half of the bandwidth in opposite direction. We have lots of the peripheral I/O integrated the design into FX20. There are 2 cross-buy interface for the external memory, 7 SCB serial combination blocks that can be used for I2C, SPI, CAN, or UART. And there's a dedicated USB full speed port for debugging and the or other purpose. This is the dedicated port other than the separated from the USB 3.2 port. We're also supporting the 2-channel audio and lots of GPIO. And there's also the hardware crypto engine built into FX20 to support security feature for the device. And we maintain the package size in 10 by 10. And with the, of course, the smaller ball page, 169 ball package is the with the good ball page that's can be designed many application using very, very small the landscape in PCB. Right, here is more detailed block diagram. As you can see that the entire the feature in FX20 will borrow from the PSAT6 FX20 by adding the green box here with the high-speed DMA from the high bandwidth data interface to the USB 3.25. And you can see the color coding for the low power mode that you can still so the chip is designed for low power operation so you can have very super low standby power by keeping the few blocks powered. All right, let's look at the heart of the FX20, which is the USB 3.25. Right. This is the completely new design by Infineon in-house that support the all the speed up to Gen 2x2 20 gig, and to support the different environment, different cable that the insertion loss of this file can go up to 28 dB. That's the best in class for all the USB interface that can support longer cable connection. And for transmitter side, it's programmable. You can do amplitude pre-shoot, the FSS programmability, and same for receiver side that is the CTLE gain and boost and the offset calibration and DFE. All this can be programmed to firmware to give you the optimal connection for your data transfer. And we also throw in this the new feature that no one has done in the past for the USB is the eye monitor that helping to do debugging in your signal issue. That so you can actually do eye diagram measurement that using this feature built into the receiver, so you can see the width and height that of your 10 gig or 5 gig connection in the firmware. This all can be done in runtime. You don't need to enter any specific test mode for this eye monitor feature. So the picture here showing here is our demo application that measuring the eye diagram over the 5-meter USB passive cable in the 10 gig of the transfer. And we also have integrated USB 2 high-speed PHY into in the chip. This can support high-speed 480 megabit, even down to 4-speed 12 megabit the connection. And total 32 physical endpoint can be used. That's 16 in and 16 out, including endpoint 0 with 2 direction. And we talked earlier about the Type-C connection with the orientation detection and correction. And so that can make you the PCB layout easier. And there's no power delivery support for FX20, but with the CC both CC pull down, you can get up to 15 watt 503 amp of power from the USB host. If you need the power higher than the 15 watt, the Infineon also provide many choice of the PD controller that can support up to 240 watt of the USB PD functions. So the high bandwidth data subsystem in FX20, that's the DMF fabric optimized for the 20 gig data throughput between the high bandwidth data interface and USB interface. So that one make excellent data buffering that can be configured for any application that so you can optimize for latency or optimize for the throughput with that 1 megabyte of the buffer memory so that also give you enough buffer room for the for your data acquisition. That if the if host side is busy, you still have lots of room to buffer in your data. So that interface can be configured as either LVDS mode or LVCMOS mode, and 2 independent narrow link, the 2 port, each port is 1 narrow link, can be combined into 1 wide link. It's called higher bandwidth, and each link can be configured independently. So you can configure one as LVDS, the other one as LVCMOS if you want. In LVDS mode, first of all, we don't have a transmitter in FX20 for LVDS connection. We have a receiver because the majority of the USB application we have seen in the past are for data acquisition, that the only delivering data from the source to the USB host. So for FX20, we only put the LVDS receiver that for the 20 gig of the performance. And so each port, there are 2 port, right? Each port will consist of 8 data lane and 1 clock lane and 1 control lane. So they can go to different source of data independently and as narrow link, or you can combine the 2 port into 1 wide link with 16 lane of data. So that the data lane can be configured that in different combination, that we support 1 lane, 2 lane, 4 lane, 8 lane, even 12 lanes of the connection, that depending the need of the FPGA that you use, and each lane can go up to 1.25 gigabit, and so there each there is one control lane for each link and one clock lane for each port that's necessary to get LVDS interface working. The maximum clock rate for the LVDS clock is 625 megahertz, and you can still communicating to your FPGA or data source via the 7 LVCMOS I/O control signal that including for each port, or you can use I2C or SPI interface to talk to your source. So there are 3 power states supporting LVDS. So you can enter the too low power state if there's no data transfer. And in the link layer, we also support Gbps 3 programmable state machine that you can configure the data to the state machine before the sending to the buffer memory. In LVCMOS mode, if you're familiar with FX3, so this is design pretty much similar to FX3. The only difference is now instead of 132-bit port, now we have 2 16-bit port for LVCMOS. That again they can be used independently. So one usage it can be the one port for LVDS by sending by using a lane of data with the 10 gig of the data delivery, and the other port using 16-bit of the LVCMOS data connection if you need to deliver opposite direction simultaneously. Right, we'll talk about the maximum data rate for the LVCMOS port earlier. That now we can support DDR up to 160 megahertz, and in RX direction, and half of the speed in the TX direction. So total bandwidth for LVCMOS node is the 10 gigabit for the 32-bit wide link in RX direction, or 5 gig in the TX direction, and also supporting the Gbps programmable state machine as before. So for FX20 CPU, that we talked earlier that there are 2 core, and one core with 150 megahertz Cortex M4, and one core for the 100 megahertz the Cortex M0, and they can be used independently. And so depending on the device and you design, that you can use M4 for main application and the M0 for security, and with combining with our cryptography accelerator in the chip, then they support the standard encryption, decryption, AES 128-256, and different hashing standards. All right. And we can do massive authentication and CRC, 32-bit CRC generator, and also the including random number generators in the this crypto engine. So all this can be very useful for the EU Cyber Resilience Act. Since we're talking about test and measurement today, that of course this FX20 can be used in the oscilloscope. We see some new mixed signal oscilloscope in the market using the RFX family, and large analyzer. Also there's one brand very popular that with our FX3, and now they're upgrading to the FX10 and FX20. There are also portable analyzer that can support the faster speed of delivering the data to your PC, and also have seen the great need of the higher speed in the spectrum analyzer. This slide show you a block diagram of the typical test estimation and the application. So we from the data source, of course, we have many ADC, analog to digital converter, that connects to an FPGA, that which packetize the data and then send those data to the FX20 via LVDS interface. Of course, that you can throw in the SDRAM memory to attach FPGA as the buffering if you need bigger buffer. And FX20 will connect to the USB host supporting Gen 2 by 2 or the slower speed that deal with the Type-C, direct Type-C connection. And there is the dedicated USB B port that can use with your full speed connection for debugging. And that cross-buy interface for FX20 can be connected to the flash memory that for the FPGA configuration. So the any updating for that your FPGA configuration can go through the fast USB connection. Let's talk about the how you can develop your application with FX20. First, you need a hardware that we provide the FX20 DVK board with the FNC connection that can be easily connect to most of the FPGA development platform that with the FNC connectors. And the so it is compact and can be bus powered from the USB. And so there we do put in the a demo color bar firmware inside the FX20 flash when DVK is released, so that you can use it to test without even FPGA using this UVC protocol, and that's to see the color bar in the application camera in the PC. So there is a full C port that beneath the PC DVK board. You can see this in this corner of the PCB. There's underneath that there's a Type-C port supporting USB full speed for debug. Of course, there are SWD and JTAG port for your firmware development and debugging. And so this 40-pin GPL accessory board connection will bring out all the signal to this accessory board that you can get, that with the audio connection and CAN connection. And in addition, we have this USB programmer that on this accessory board that you can this is connected directly to the SWD port of FX20, so that all the programming and can be going through this additional USB connection. So you don't need to buy the additional hardware for your Cortex development. For the software development, for USB Easy USB FX20, we provide Modus Toolbox and Easy USB Code Builder. Modus Toolbox is the IDE tool for all Infineon microcontroller devices, support all the major OS, including Windows, Linux, and Mac OS. And also that you can find the BSB for the FX20 DVK in the Modus Toolbox. And the best of all, the Modus Toolbox can give you is the development community that they can share many article knowledge and the documentation. All right, so you can find lots of the good information that from the community, and also can ask question in there, and our supporting standby and will answer your question very quickly. The Code Builder is a new tool we developed to jumpstart your firmware development, so also supporting major OS. And so this is a very easy tool to use. You just click the configuration that select anything you need for your application, and this GUI will generate a compiled firmware code, the hex code for you to program to your device right away. You can also export the result back to Motor's Toolbox if you need to modify the firmware. So this is definitely will save you a lot of time for your firmware development. So since we introduced the FX10 in end of the 2023, early adapter has used it for upgrading their current design. So we're going to use this as example. This is the spectrum analyzer from Aronia AG, and I think it's in Germany. So the spectrum analyzer used the two FX3 to provide the enough bandwidth for their analyzer. So you can see there are actually two Type-C port in the back dedicated for the data transfer, and additional the power Type-C port for the PD support for powering the whole analyzer. But now with the one FX20 that can deliver 250% more bandwidth than the two FX3 combined. And also now with the less chip and the more power efficient design, so everything can be powered to one Type-C port. This is a much better design than the old one. Okay, so FX20 family actually including 3 addition controller, from the USB 5 gig, which is FX5, and USB 10 gig support with the FX10 and FX5N. All 4 products in the family actually has been certified by USB-IF. Beside this new product family, we also have the CX3 and FX3 for 10 years, supporting USB 3.0 or 5 gig connection. So CX3 is the MIPI to USB bridge that's supporting 2.4 gig of the bandwidth. And we talked about FX3 earlier. So both chip can support maybe up to a 5-meter passive cable with the USB 5 gig connection with the one ARM9 the processor. You can compare to the new product family so you can see how much improvement we have done in the new product family. The all new family are available now. So you can go to the website to download data sheet and or request samples through your distribution channels. So this is the complete building blocks that Infineon provide to solve the problem of the adoption of the faster USB 20 gig interface. The benefits for the new Easy USB portfolio, including faster performance. With FX20, you get up to 600% the performance boost over FX3, or 300% for the FX3. And smaller PCB footprint with the less external component. So with integrated flash and direct USB-C connection, now you can save more PCB space for your device. And best of all is our support that we provide both great software tool and hardware tool mini co-example to support UVC, USB 3 vision, and all this and combined with this great debugging capability and our supporting will help you to deliver your product to market as soon as possible. All right, beyond test and measurement application, there are other applications can leverage USB 20 gig or 10 gig the interface. So in the image and the video, we have the machine vision camera, medical camera that can use this new interface, faster interface, deliver the raw imaging data. You can do in scanner with 3D scanners, document scanner, or the intraoral ultrasound scanner in medical application. Also in APJ modules, so many expansion card, SOM, and baseball will have the FX20 for the easy USB connection. And for the emerging applications such as the XR, MR headset, and or augmented reality headset that which getting very popular today, that so they can use the faster USB interface for multiple camera to deliver the mixed reality, that immersive experience for the headset. All right, the key takeaway from today's webinar. So Infinite Easy USB FX20. Remember that earlier we talked about the 3 challenges that prevent USB 3 beyond USB 3 to grow. That this entire ecosystem facing a lot of problem. So today with this new Easy USB FX20, so we provide these great building blocks from the product family that providing USB 20 gig interface to your new test measurement applications, right? And that with the new best in class USB 3.25 that we can support that up to 5 meter passive cable for the 10 gig or 20 gig data throughput. Right, so that solves you the cable length problem with this high bandwidth the 5, and so we provide great tools and also this complete portfolio that can be used for different skill of the new USB application, now including FX20 for the USB 20 gig connection, FX10 for the USB 10 gig connection, and FX5N by using Gen 1 by 2 connection that it can support 10 gig connection with a much longer cable. And also FX5 replacing the old FX3 with the longer USB cable connection, supporting USB 5 gig connection. So if you need more information, that here you can find the link to our data sheet, white paper app note, right? And also can download the software tool with provide a link. If you have any question, that you can also talk to our supporting with the link. And that's it for today's webinar. Thank you very much.
All right. Well, thanks, Jimmy, for that great presentation. I'm old enough to remember when USB data rate was less than 20 megabits per second. So supporting data rates that are more than 1,000 times higher than those early USB products is really a testament to the ingenuity of electronics engineers. So great presentation. We already have several interesting questions, but I want to let our audience know that there's still time to submit your questions. Just use that Q&A box on the right-hand side of your screen. And Jimmy, you ready to answer some of these questions?
Sure.
All right. First one is asking, what common challenges do engineers encounter when integrating USB 20 gigabit per second into test and measurement devices?
All right. That's certainly a good question that that most engineers are facing. So I guess the number one is like I